Have you ever just stared at your phone or your computer and had that moment of how? I mean, really, how does this little slab of glass and metal do all this magical stuff? Well, today we're going to pull back the curtain and find out. There's no magic, just some incredibly clever engineering. Now that pretty much sums it up, doesn't it? It's a totally fair question. We're all walking around with these mysterious black boxes in our pockets, powered by what feels like some kind of digital sorcery. We use them every second, but how they actually work, that feels like a total mystery. So that's the big question, right? And that's exactly what we're going to unpack. We're going to break this whole thing down piece by piece, starting from the absolute smallest component and build our way up to the digital brain that's running our world. To really understand this machine, we have to start small, and I mean really, really small. We need to find its most basic building block, the single atom of computing, if you will. And here it is, meet the transistor. Now, don't get hung up on the technical sounding name at its core. A transistor is just about the simplest thing you can imagine. It's a switch. That's it. A microscopic lightning-fast light switch that can only be in one of two states, on or off. Everything, and I mean everything, is built on top of that one simple idea. So we've got a bunch of switches. Great. But how in the world do you get from a simple on or off to sending an email or streaming a movie? Well, you need a language. And it turns out the simplest switch in the world gives us the simplest language in the world. And this right here is the crucial connection. The physical state of that tiny switch, it translates directly into the computer's language, which we call binary. When a transistor is off, the computer reads that as a 0. And when it's on, you guessed it, it reads it as a 1. It's that simple. And this is the part you really got to wrap your head around. Every photo you've ever taken, every song you've ever heard, every single thing your computer does is deep down just an unbelievably long string of these ones and zeros. It's just billions and billions of tiny switches flipping on and off faster than we can even imagine. Okay, so now we have our alphabet, zeros and ones. But just having an alphabet doesn't get you very far, right? You need rules, you need grammar for a computer. The next step up the ladder is to combine these switches to do something way more powerful to make a basic decision. And we do that with something called a logic gate. You can think of it like a bouncer at a club. It takes in a couple of inputs, like is your name on the list and are you over 21? And based on those inputs, it gives a single simple output, yes or no. It's the very first glimmer of what we might call thinking. Wow. And this is where the scale of it all just becomes absolutely mind-boggling. We start with one simple on-off switch. Then we bundle a few of them together to make a logic gate, a simple decision maker. And then we take that idea and we multiply it by billions to create the central processing unit, the CPU, the brain of the whole operation. So we finally made it to the brain itself, the CPU. This is where all those billions of logic gates work together to perform these incredible calculations. But the CPU has it has a very strange personality. There's one analogy that just captures it perfectly, and there it is. I think this might be the single best description of a CPU I have ever come across. Just perfectly nails its amazing power and its one huge weakness. Let's break down what that actually means. So on one hand, you have the genius. CPU can rip through billions of calculations every single second. It is unbelievably fast at maths. But on the other hand, you have the goldfish. The CPU has practically zero memory of its own. It'll do a calculation, and then poof, it's gone. It completely forgets the answer unless it's specifically told where to store it. You know, this brings up a funny little detail. You might have seen programmers use stuff like hexadecimal and think it's some complex computer language, but here's a secret. The computer has no idea what that is. It only, and I mean only, speaks in ones and zeros. Hexadecimal is just a convenient shorthand we humans invented. So we do go crazy trying to read endless pages of binary code. It's a cheat sheet for us, not for the machine. Okay, let's zoom all the way back out. Remember how we started this journey with a grain of sand? Well, that sand is where we get the silicon to make all of these transistors. So we've literally gone from sand to a supercomputer. It's just an incredible story of scale. So let's just recap the building blocks real quick. It all starts with the atom, that simple on-off transistor. That gives us the language binary, our zeros and ones. We combine those to make the decision with a logic gate, We scaled that up by billions to create the brain, the CPU. And if you want one last number to just completely blow your mind, look at this. A single modern processor, the kind in your phone or laptop, can have over 50 billion of those little on-off switches. 50 billion all working in perfect harmony, all built from that one ridiculously simple idea. Which kind of brings us to this final lingering question. We've seen how the machine is built from the switch all the way up to the system. But if it's all just ones and zeros, if it's all just a chain of simple yes or no questions being asked at blinding speed, at what point does that become intelligence? Where's the ghost in the machine actually lit? Thanks for watching, and remember to subscribe, like, and share.